Okay, so today we're going to be talking about the periodic table, essentially the basics. And I apologize for the stuffy nose sounding voice. I had tried to wait and wait to make this recording, but it just never got better. So here we go. Periodic trends. So here's our goals after today's lesson. We're going to describe how the modern periodic table is arranged. And we're going to talk about some of the similarities and differences among the groups and the periods on the periodic table. Locate and label common groups on the periodic table. We're going to talk about the properties of metals and nonmetals. And we're going to talk about what a metalloid is. So it all started with this scientist, Dmitry Mendeleev, in 1869. So he arranged the elements in increasing atomic mass. So elements in the same row have similar properties. So this is the first way the periodic table was arranged. And if you're writing notes right now and you have the guided notes, you'll be writing everything in blue. So I'm going to pause here and give you a moment to record these notes. And if you have access to this PowerPoint, which you should on Google Classroom and the class website, you can click on this TED link about how Mendeleev arranged the periodic table. We're not going to watch that right now. Okay, so how is it arranged today? It was arranged by increasing atomic number. That was by a scientist named Moseley in 1913. And again, this is how it's arranged today. If you look at your periodic table, you'll see there's a very clear pattern. It goes from 1 to about 118. And they're all in somewhat of an order there. Okay, so here's the periodic law. So when elements are arranged in order of increasing atomic number, we're going to see a pattern, a periodic pattern, and that's in physical and chemical properties. So what's a period? So if you can see in blue right here, a period is going across. So this is your horizontal row of the periodic table. We call it a series. If you look at your periodic table, you'll see numbers along the left-hand side, and those would be the number periods. And then alternatively, we have groups, which are the up and down columns, vertical columns on the periodic table. And these are numbered 1 through 18 across. We could also call those families. All right, so elements in the same group have similar properties. And remember, the groups are the ones, the columns, the up and down columns. And again, 1 through 18, you see that at the very top of your periodic table. So elements in the same period don't have similar properties in the same way that the groups do, but they do have some patterns. Again, those are 1 through 7 on the left-hand column of your periodic table. But what they do have in common is the same number of occupied energy levels. And we're also going to talk about some trends as we move across periods in the next PowerPoint. Okay, so we're going to talk about just kind of the setup of the periodic table. So you need to recognize that this middle box right here, the one colored in yellow, is our transition metals. And then the elements and we'll say the columns are higher, if you notice that, right? So they're a little higher up. They're colored in blue here, and we call those representative elements. So the S and P blocks, so that's when we did our electron configurations. We had S and P. So if the electron configuration ended in an S, it would be these elements here. And if our electron configuration ended in a P, it's going to be these elements here. And both of these, again, are called representative elements. Now for our transition metals. These are the D block. So when we do our electron configurations, these end in D. And then we have the inner transition metals. Now it's not shown in the picture, but if you check out your periodic table at the bottom, we have our two rows, our lanthanides and our actinides. For right now, you don't have to memorize that, but what I do want you to know is that those are the inner transition metals. And I'll point this out to you in a little bit. And again, those are the F block, the inner transition metals. All right, so now we're going to talk about some names of groups on the periodic table. I'm just going to tell you the ones that you need to know. And then I'm going to point this out too, just because we just talked about this. So the lanthanide, the actinides, these are not attached to the periodic table. These are our inner transition metals. So these two periods right here. Okay, these are your inner transition metals. Now let's talk about 1A. Okay, group 1 or 1A. You can see how there's a 1 here and then there's also a 1A here. So we're going by both of these numbers. As we get further to the right, we're going to talk about why these numbers are different. Anyways, 1. These are your alkali metals. These are very reactive. Okay? This group right here wants to lose an electron. Then we have group 2. These are our alkaline earth metals. Okay? And then we're going to jump over here. So we have group 17 or 7A. So you'll hear me referring to both of these in class. So remember that we have 17 and we have 7A. So these are the halogens. And then 18 or 8A, we have noble gases. So the reason why we use these bottom numbers, so these are going to tell us the valence electrons in this group. So it doesn't have 17 valence electrons, it has 7. These have 6, these have 5, so on. And then 1 and 2, those fit, right? So 1 valence electron, 2 valence electrons. We don't do that for the transition metals though. So it's only our representative elements we do that with. All right, staircase. So here it is. Starts at boron. And you're going to draw this in your notes right now. So you're going to draw in your staircase. Let me go back there. So this is our staircase. We're going to find our metalloids. So this is going to be in your notes further, but I do want to point this out now because we have an illustration of our staircase. All of this to the left of your staircase. I'm just kind of highlighting it yellow so you know a little bit what I'm talking about. Obviously, this could be better. All this stuff. Okay, these are metals. These are metals. So anything touching the staircase, except for aluminum, is a metalloid. So aluminum is a full metal. Hydrogen is our exception there, right? So there's always an exception in science. Can't get around it. I teach your rule, but then there's always something or, an exception to that, right? Okay, so hydrogen's a nonmetal, right? But everything to the right of the staircase is a nonmetal. Okay, so I'm just highlighting this in here for you. Now our metalloids touch the staircase. So you need to know this. Okay, metalloid. See, it's touching that staircase that we drew in here. Metalloid. Alright. And I did not highlight helium. Let me just do that just for some clarification. Okay, this is a nonmetal. How can you remember this? Well, if you can't remember the left and right thing, think of oxygen. Alright, are you breathing in metals? No, probably, no. So Oxygen's on the right of the staircase. That's my best way to get you to remember that. There's other ones too, like if you can remember lithium batteries. Lithium's over here to the left of the staircase. Lithium is a metal. You would think that your batteries are made of a metal. I'm highlighting the inner transition metals down here, so that doesn't really cover our rule, but if you remember that they're inner transition metals, you should know that they're metals. All right, so let's talk about metals. Okay, we just said this. Left of the staircase, metals, non-metals, right of the staircase, but we're including hydrogen on that. Hydrogen is a non-metal. Metals are shiny. Think of coins. Think of your jewelry. Our non-metals are dull, non-lustrous. Metals, malleable. You can hammer them into thin sheets. Ductile, you can make them into thin wires. So if you think about electricity, what's on the outside is a non-metal, like rubber. And inside of the wires is a metal. It's made into a wire. And that brings us into conductivity, right? So metals will conduct your electricity, and what you want on the outside of your wires is a non-metal. So a poor conductor, it's not going to be conducting electricity, but it makes a good insulator, so it keeps heat in. All right, and then metalloids, so they touch the staircase, and they have properties of both metals and non-metals, but we're excluding aluminum in that. Again, there's an exception to everything. Aluminum is a metal. So metalloids are semiconductors, so they don't normally conduct electricity, but they could at high temperatures or when certain substances are added. So, it really depends on the metalloid, but for now, this is what you need to know about them. They have properties of both metals and nonmetals, and they touch the staircase. Okay, so this up here is your most important notes on the metalloids. And then in your own time, not in this lecture here, we'll probably watch this in class if you're in class, but alkali metals and water, I said the alkali metals again. Let's refresh that. Okay, we're in group 1. Okay, right here. So these are very reactive. These are most reactive elements here. They want to lose one electron so badly that they will react pretty much with everything. And they are especially reactive in water. So if you want to check out that video, you can see that they take, I think about the first 3 or 4 alkali metals and show like how the reactivity goes up as we go down, but how they behave kind of the same chemically. So that's why this video is here for you to watch. And that's about it. If you have any questions, just let me know. Shoot me an email. You have worksheet 1 in your packet, or there's a link for it in Google Classroom. So that is homework. All right. Thanks.